Nobody asked for another podcast, so here you go. This is yet another Infra podcast.
Hi, everyone, and welcome to our fifth episode of yet another Infra podcast. I'm your host, Vitaly Gordon, co-founder and CEO of Ferris AI. We have a great episode for you today. We're joined by some awesome guests, Ian Livingstone, advisor to Sneak, Hassy Veldstra from Artillery.io, and Alex Clemmer from Moment.dev. Some of the topics we will be covering include, why don't we have good APIs gateway for frontend? Is there such a thing as overnight success in infrastructure? And is no-code a thing or not? Hope you enjoy. Hey, everyone. As we discussed in the first episode, much of the exciting tech development is happening in the front-end world. This sparked a conversation about the impedance mismatch between front-end teams and back-end technologies. So Hassy, as someone who spent a lot of time building back-end for front-end, can you describe your experience building these systems? And what do you see as some of the gaps in the market right now?
Yeah, sure. I'll maybe rewind back to the original message that kicked us off in YAG. So Ian mentioned something about API gateways missing this piece at the moment, which is to make it easier for developers to essentially program them directly and to be able to pull data from other sources, transform it, and return it to the front end. And when I saw that, I thought, yes, absolutely, this thing needs to exist, but for some reason it doesn't. And to add context to where this strong sense of pain comes from is my involvement in several digital transformation projects, right? And for those who might not be fortunate enough to have experienced a digital transformation project, usually what happens is a big enterprise. There was actually a great example in one of the previous YAG podcasts. So imagine the largest manufacturer of frozen pierogi based in Pennsylvania in the United States. They have an IT department. They might have a software development team. They definitely rely on software for everything. And they also possibly build software in-house. In my context, it would have been one of the largest furniture retailers in the UK or one of the largest holiday tour operators with revenues in the billions. And so digital transformation is what happens when the leadership recognizes and buys into the idea that in the future, every enterprise company is going to be a software company. So they go, oh shit, essentially, we need to become better at building, running, and operating software at scale. And that's what kicks off those digital transformation projects. And they can span years. So I would usually come in as part of a team that today would be called platform engineering or something like that. Back then, it would have been called a DevOps team or something along those lines. And so the pain that you run into is that as a full stack developer or a front end developer, you're dealing with a lot of legacy code and a lot of legacy APIs, and you're usually building a new front end to work with those APIs. And you run into the problem of them not really fitting your data model, not being nice or ergonomic to work with. You want something much easier. And then being a Node.js developer, what you usually do is you spin up an Express server on your laptop in 30 minutes, and you get to shape the data in exactly the way that you want. And that makes sense to your front end. So that's the kind of one side of that pain, which is as a front end developer, the backend team aren't listening to me or aren't moving fast enough. So I'll put a layer on top of that, a classic computer science thing, another level of indirection, and I'll solve that for myself. The other side of the pain comes when it's time to put those services into production. So then if you're in a DevOps team or a platform engineering team, someone comes to you and all of a sudden you realize, oh, there's all these new microservices that have to be put into production with all of the overhead that comes with that. We already have an API gateway that fronts everything that we have. Wouldn't it be nice to be able to do all of this stuff right inside the API gateway? And I post a message in that channel and it seems to resonate with a lot of people. And it seems to be a very common problem that all sorts of teams run into, not even necessarily at least older cross-tier enterprises, but even some of the more forward-thinking tech companies.
Yeah, speaking of API gateways, actually, Ian, you also participated in this discussion, and you said that one of the greatest misses thus far is that API gateways are typically marketed to backend engineer instead of focusing on enabling front-end engineers. Could you explain what you meant by that?
Yeah, absolutely. For background, I'm helping Sneak the last 2 years go through a transformation monolith to microservice. How do you go from a series of tools to a platform? And in that time, one of the major things I've watched is this tension between people trying to drive the UI, the needs of the UI, and this tension between people trying to produce APIs. And I think Hassy really encapsulated this point really well, is that there's an impedance mismatch between the needs and how these people approach the problem. One is approaching it from, I must drive a UI. I need different types of data. And from a back engineer, it's like, well, I have this data in my database. It is expressed in this manner. And those two things are often very different, right? And so a front engineer is trying to figure out, how do I hydrate or get data from a series of back-end APIs to my front end? And how do I do it really effectively? And how I do that in a way that's oftentimes very unique to that specific like user workflow, right? And there are technologies, we talked about like GraphQL is an attempt to solve some of these problems. But when you think of a large enterprise organization or any organization that is just beginning to be API first and just is moving on their journey around, let's build services, let's have APIs, REST APIs over those services, enable data access. You have the front end cap aspect, which is I need to consume these APIs, somehow create UIs from them. Oftentimes there's this mismatch between I as a front end engineer need something different in the way that you're expressing it. And so you end up with this layer. Right. But if you think of what this layer is actually doing, this backend for front end is doing is it's stitching a whole bunch of different service calls together into one service call. So it's really just doing effectively like a much smarter proxy. And if you think of what an API gateway actually is, it is a programmable proxy that allows us to do some extra things on top of it. So from a technology perspective, you can look at API and gateway. You can say, if you're in the right place in the organization, in the tech stack to be able to do these things, but there's no workflow that enables me, the front end engineer, to say, hey, let me stitch all these APIs together to render this view and it be different REST APIs. And so one of the things when I think about infrastructure and when I say it's a miss is I think infrastructure is amazing. If you really want lock-in and truly enable new workflows inside your organization, is you got to solve a workflow. And there's a missing workflow, but that helps back-end engineers and front-end engineers be more productive together. And that's here right inside the API gateway.
Awesome. Alex, I would love to hear your thoughts as well on this subject.
So I think there's like some indication that the space isn't super mature yet, because I think a lot of companies are starting to think about what would traditionally be infrastructure problems and bringing front-end people into those problems. And I think the best example of this is Vercel. So one way to think of Vercel is basically as like a React Native CDN. And I think on the face of it, that would have, especially in 2017 or 2018 or whenever they got started, seemed like a pretty dumb idea. But the CDN sits on this organizational seam where the front-end people want to ship code and want to ship like apps, and the back-end people mostly want to ship APIs. And what Vercel did was allowed front-end developers to accidentally become back-end developers, and then convinced also the back-end people that it was better that Vercel manages like the deployment of these little node apps with bespoke backends inside of them. And it freed up the back-end engineers to concentrate more on what they wanted to concentrate on, which is like APIs, and the front-end engineers to concentrate more on what they wanted, which is like getting apps to production. And the server-side rendering component of this is like this elegant punt, because it lets the front-end engineers make backends and not upset the back-end engineers who no longer have to manage these complicated CI/CD pipelines. And when you think about what that means, I think the server-side rendering, the server-side properties of Next.js are kind of a compromise, and they can act like an API gateway because front-end engineers can build this bespoke bridge logic between the underlying backend APIs, and they have access to stuff that helps them authenticate against them, but they don't actually have to talk to the CDN team or the API team, and that makes them a lot more effective. So I'm really excited to see this next wave of the companies think this through from first principles at the API gateway level as well. Yeah, I think this is a really interesting exercise in product design and positioning, actually, because the pain is definitely there, right? In various companies, various forms. And we have all of the tech blocks to build something like this, but the thing doesn't exist. And having tech blocks doesn't make a product, obviously. Otherwise, we'd all be using Linux on the desktop. And as members of YAG, we know that product is what you make easy for people, right? So if this thing existed, I think an interesting question is, what would it have to make really easy? And also in what sequence for it to actually take off, right?
Absolutely. And I think that's a great transition to think about, what do you need to take off? What do you need for this to be an organizational enabler? To date, if you look at the product marketing for API gateways, it's about enabling surge-oriented architecture or enabling these different mesh architectures, but it's not about like enabling new productivity gains for new consumers. And so I think one of the things we'll see is as we switch to the concept of platform engineering, we focus more on enabling layers that enable builders on top and less on what has always traditionally been more like a waterfall or siloed DevOps concept. We're going to have a world where as an engineer building backend services, or maybe even less engineers building backend services, we'll focus more on here's the data we want to represent, and then how do we stitch that together? And that's where these API gateways are super well positioned to have this really important translation layer that sits between people that are building like core infrastructure and services and dealing with the really hard problem in the organization, and the people that are trying to just build UIs and experiences for people on the other side.
Awesome. So switching gears a bit to talk about how infrastructure companies are created. Recently, there was an interview with Elad, who's one of the most prominent investors in Silicon Valley, where he said that the reality of most companies is they're either work quickly or not at all. This sparked a large debate on the channel on whether this is true for infrastructure companies. Ian, as a founder of several companies and investor in many others, what do you think about Elad's position?
Yeah, I think Elad is obviously very smart, but Elad comes from a deep consumer background, right? And in consumer technology, it's very true that you kind of have these hyper viral, explosive moments, these massive like hockey stick moments that occur. And it's usually very early on because usually consumer products have some type of unique iteration on some experience. So we think of like Snapchat, the message disappears and that enables some type of new form of communication that some portion of the population is hyper excited about. Instagram, photo sharing with the filters that makes my camera look better. There tend to be small iterations in a big markets and that spread very quickly. And I think when you go and think about infrastructure companies specifically, it's like almost the opposite of this, right? A lot of infrastructure buying is one, we have to go build a deep piece of technology that's a deep enabling layer that we don't have before. So you have a huge amount of upfront investment, but also the buying behavior in consumer, it's very different. It's easy. My friends share with me. I try it out. I usually don't spend money. Right. And even if I do spend money, it's a small amount of money. It's very driven by what my friends are doing and word of mouth. And that's true in enterprise to a certain extent, but the buying behavior and how I try things out, how I build trust to actually take this piece of infrastructure someone's trying to tell me and build it core part of my business, right? And build with the trust to build that and build that out, deal with the integration, and then also make the decision to actually buy and spend is significantly longer. And so they're different poles and different opposites of the spectrum. And that's why when I think of Elad's position as like doesn't translate to some of the most important company and examples we have, like a Databricks or a Datadog or a MongoDB. These are all examples of companies that were deep, long in the tooth investments. And we didn't really realize their massive opportunity until the very end of their sort of S-curve investment.
So Alex, you're a founder of an infrastructure company yourself and have been going at it for about 2 years now. Yet we don't hear about your company as much as we hear about Google or Apple. What do you have to say for yourself?
Okay, thanks for the spicy question. My position on this is the kind of thing that when I hear an investor say it, it makes me take them less seriously. And there are a lot of reasons for this. One reason is in the last generation of infrastructure companies, I'm not sure I can think of even a single example where it was very clearly working early on. So you look at like Datadog, Snowflake, right? Like Snowflake Series B was $60 million post. It just took a long time to get these companies started in any appreciable way. And that was an era where there was a lot more low hanging fruit to pick over, right? Like the idea that we're going to build like a unified logging product or like a unified cloud data warehouse or something, like these are not ideas that are available for people to work on anymore because a lot of core infrastructure has been built up. And my sense is that the next generation of companies are going to have a much harder time building core infrastructure products from scratch in a way that is similarly time efficient. And what I would say to founders is that I think it's a mistake to compare yourself to the previous generation of companies in general, because all of those product tricks and all of those wedges are like now used up, right? And now I think we're entering a different phase of the market where it's not entirely clear that you are going to have like super clear, super efficient paths to market. And so that's one is I don't believe that we have a lot of examples of this being true in the infrastructure space. And the second is the go-to-market is comparatively a lot more complicated for enterprise and infrastructure companies. So you have to actually build out the muscle. You have to figure out how you get into these accounts. I've said this before on the podcast, but a lot of infrastructure companies have very few technical buyers, which makes the spaces very hard to sell into. So if you're selling a complicated technical compute product, you are probably going to have like tens of thousands of technical buyers. And that means that you're not looking for this hockey stick shaped growth curve. You're looking for like saturation of the space because you have to win 100% of those companies in order to IPO. What do you expect when you're going to market there? It's not necessarily clear to me that you expect that it is going to be super clear that it wins. I think what you would expect in this sort of saturation go to market is
You are winning accounts one by one. And as you win them, there are like signs of virality in the organization. There are signs that people are picking this up and using this everywhere. And you think about something like Temporal. Temporal is a pretty good example of this, where it lands in an organization and people start using it everywhere. But it also took them 10 years to figure out how to get that go-to-market going. So I don't know. To me, this sounds like an aphorism, like a fun platitude that you say to encourage people to like act with urgency. But as a founder, I'd prefer to hear directly, you need to move with more urgency on these points. I would rather hear that than you need to be more like this other company from this other generation of startups. That's just not a helpful comparison.
Yeah. So as a infrastructure founder myself, but previously I was a VP engineering at Salesforce, where actually Ian and I overlapped a little bit. And I can tell you that as a buyer, there is something true about the say that no one gets fired for buying an IBM. You just don't want to run your critical workloads on a 1-year-old startup. And that's just not how things work. It doesn't matter how viral you are, how many posts you get on the Hacker News. It just takes time for technologies to mature in order to be reliably used in critical workloads. And that is what startups have to work for a long time in order to get to that point. Hassy, I would love to hear your thoughts on this as well.
Just a big plus one to what Alex said to what you were talking about. As someone who's building an open source tool for developers as well, this is something that we're seeing firsthand. It takes a very long time for something to start getting used in production on real workloads. We're seeing projects on Hacker News every day, and their GitHub star accounts just fly up, but it takes a long time before someone actually starts using it in production. And another counterexample that came to mind immediately was Terraform. And they didn't have any external users for something like the first year of Terraform's existence. And then I think in the second year, they had 2 or 3 users, literally. But what kept them going was that they were high signal users. PayPal, I think, was one that they mentioned. So yeah, infrastructure and dev tools, things just take a really long time.
And I think like the one way I often think about dev tools, I think about why these different things take at different times. When we think of that spectrum I talked about before, you have like consumer on one hand, which is like easy to try, hyper viral, like explosive growth when they work and super iterative. Then you on the other side, you have these like core infrastructure things like I'm building a new database, right? I'm building a new compute infrastructure like Snowflake. There's this middle ground, right? That's like the prosumer enterprise tools. If you think of the complexity, if we think of our apps, you think of what we're buying and where it sits in the stack, it's like an onion, right? And each farther you get out to the surface, in terms of the app, it's a lot easier to adopt. It tends to be more viral. It tends to have different growth curves, right? But it's like further down the stack, it's like bigger price tag, more important to the buyer, more trust required, more proof points required, longer sales cycle. And the virality of how those things get adopted is different. And so we're also seeing a lot of virality in like dev tool space for, let's say, front-end engineers, right? There's a lot of things happening at the Vercel layer, which aren't taking as much time because they're packaging up like infrastructure that exists and making it accessible to a new group of users. And so those companies are different. But all of these moments and all of these dev tools, infrastructure companies, independent of where they sit in the stack and how they do, have a drastically different buying behavior and adoption behavior than consumer ever does, even prosumer tools.
Yeah. And so to talk more about the adoption behavior, we also need to talk about that probably one of the things that I would argue defines an infrastructure company is low churn rates, right? So if you have a 5% annual kind of churn rate, it just means you're extremely sticky, right? And like you just cannot expect to dethrone a company that has such low kind of churn rates and just replace it with a tool that just created. You just have to grind it years over years. And in some cases, there were companies that it took them a decade to actually establish a prominent position in the market, like MongoDB is one that I can think of that we all remember the joke. So Mongo is web scale and it's losing data and all that. And now it's actually one of the more prominent public companies, but it definitely was not an easy solution, even though they actually had quite a lot of developer adoption at the beginning.
So the other thing that I'll say is what we mean by works actually matters in this discussion. So if you looked at Docker in 2016 or something, I think a lot of people would have said that it's working, but really what was working was distribution for the open source product. But it took them a really long time to figure out how they were actually going to ship the product. They had essentially had to rip apart the company, reconstruct it from scratch, and build a business from first principles. And what was true is that they became a distribution mechanism for a whole bunch of other companies on the stack above that actually were successful. If you take Elad Gil at his word, it's like A company that is going to succeed early, and it's going to succeed consistently. I think like it's a difficult claim for me to swallow because I don't think people even really know what we mean by that. There are a lot of companies that will trade off profitability and like working in the business and go to market models. And those companies, like the infrastructure is littered with companies that never figured that out, right? Heptio, CoreOS, Mesosphere, Docker. So I think if you're going into this, I don't know if you can have a super clear picture ahead of time, but it is important that you at least have beliefs about what you think success looks like in your space, because there are a lot of sides of success that if you optimize for will actually kill your company. And if you over optimize on something like distribution too soon and under optimize on go to market and product, you will blow your company up. So be careful.
So actually, Alex, as our kind of resident expert in the topic of why X did not succeed or why did X fail, like why actually Docker failed? Because if you would think about a VC model that tries to predict which companies will go big, you would think that a technology company that has distribution and usage by basically every single company in the world, from small startups to like larger enterprises who are all using their product in their most sensitive workloads, that is pretty much the best guarantee for the success. But somehow it didn't happen. I'd love to hear your thoughts there.
Oh God, I'm the what failed at X guy on the podcast. So Docker is pretty interesting because I think of Docker as pointedly not reinventing the wheel, right? It's like a better API for processes. It lets you apply limits to processes, and it lets you package up processes and then send them to another box. And that's a pretty good idea. That's definitely a thing that a lot of people in the world are going to use. I never like worked at Docker or anything like that. From the outside, it seems I did work at Heptio. I was like a very employee of the company that was founded by two of the three founders of the Kubernetes project. And I did 80% of the Windows integration work from Mesos while I was at Microsoft. So I worked super close to Mesosphere, and I know those founders very well. And I can tell you what we thought from the perspective of those companies, which is it felt like Docker was distracted on stuff that didn't really matter to what they were trying to accomplish. In general, like the space is riddled with turf wars. So like people believe that it's important to have thought leadership. And so they really optimized for thought leadership and trying to suck up all of the air in the space. And they raised enormous amounts of capital to pull all of the air out of their competitors' lungs. And it just didn't matter, right? Like the thing that mattered at the end of the day was building a sustainable business. One thing that Heptio did have over Docker, which may or may not have worked in the long term, we'll never know because we got acquired, was that they actually had a thing you could charge support for. It is a blessing and a curse. Like support contracts are crack and you will get addicted to them, but it gives you an opportunity because over the long term, you have the ability to build businesses around the support. So there are companies that have been somewhat successful doing this, like Cloudera, and that gave us the opportunity to succeed in a way that Docker did not. Docker never could offer support contracts. It was just really hard to build the business that they thought that they wanted to build, at least what we thought they wanted to build from the outside. In the end, it doesn't matter because Docker may end up being the only commercially successful company in the space because they are actually charging for Docker Desktop now. And it is a model that is actually working. I don't think that this was intuitive to pretty much anybody in the space. Everybody thought the key monetizable application was the server side. And I think that's just like a giant cosmic irony that all of these other companies that were prestigious that got acquired may end up not actually being very good businesses. And the one business was the business that nobody actually wanted to be in because it was not cool. And all you had to do is to reconcile the belief that you had to do was to be honest with yourself about where the business actually was. And that for a lot of companies is very difficult.
Yeah, I think those are all like really salient points, Alex. Like one of the things I want to jump back to, Vitaly brought up MongoDB. And I think one of the other fundamental differentiations that kind of happened in enterprise companies, like MongoDB for a long time, web scale, heavy adoption by developers, but there was always that crowd that kind of considered it. There's issues with like its transactionality and its ACID compliance. It's really truly an ACID compliant database. So one of the things enterprise you can do in the enterprise and do in infrastructure is as long as you have a path where you know how you're going to charge. So I think the first part with Docker is how are they going to monetize? Like it was always this fundamental question. They lost this battle with Kubernetes and clusters and a bunch of other things. And it turned out the registry wasn't super valuable as we thought because it was hyper really repeatable. There wasn't a ton of lock-in. But one of the things that Mongo did really interesting is they won the hearts and mind of the top front developers in terms of here's a better way for you to store your data, seemingly to them. And there's lots of controversy about whether it is or it's not. But then over time, once they figured how to win, they actually ended up acquiring the ACID compliant piece, which completely repositioned the company once they solved that part. So that's one of the things you can do in enterprise, but really in infrastructure is as you progress and as you win certain parts of the market, you can change out the underlying ground pieces and reposition yourself into deeper enterprise markets, as an example.
Yeah, I think full stack JavaScript developers and front end developers actually deserve a lot of credit for infrastructure products taken off. Like Mongo, for example, I was on a couple of teams that adopted Mongo really early. And all of that transactional stuff, the stuff that backend developers and DBAs really care about, it didn't matter because it was so easy to work with as a full stack developer. Docker Desktop is probably the same, right? Who's paying for licenses for Docker Desktop? It's probably full stack and front end developers in enterprises. And yeah, who knows, this API gateway thing that we're talking about, that could be the next big thing, right? Because that's who'd position that if someone builds it.
I would also add that probably one of my biggest misses in this world, coming from a kind of a heavy backend systems background, is just completely not understanding how important ergonomics are to a successful technology. Everything from JavaScript to Mongo, and also even in the AI space, things like PyTorch, they all won not because they were the best or had the highest reliability. They all had the better ergonomics. And it's just enough for enough people to start using that technology for even person project and then bringing it to their job. And I would say that probably I'm just wondering how many investors missed that signal in the last couple of years. But let's jump to our next topic and talk about kind of some of the other things that are happening on the server. So one of the great thing about this Discord server that sometimes the members just wake up and choose violence. That was the case a couple of days ago with Martin Casado from A16Z tweeting that no code is not a thing. This stirred quite a reaction on Twitter. So Alex, can you expand on what Martin meant by his tweet and where do you stand on it?
So I think there's like a sort of persistent confusion around why we call it no code at all. Like it's just a GUI. So historically you have a lot of different ways of managing complicated asynchronous workflows like business process automation. There's like a lot of tools that do this sort of thing. When you think about something like Zapier, it's like, why call it no code? Like why define your company in terms of something that you want to have no relationship with? Right? It's just a GUI for like process automation. And if you go around and you look at a lot of products where you have this high degree of customizability built into the GUI level, not that many of them are calling themselves no code. I think the reason is because traditionally you have to have infrastructure engineers to do integration. You have to like integration engineers to actually stitch together all of these APIs. And I think what Martin is saying is it's a little bit strange to call that like no engineering or no code because that's the identity of the product should be defined by what it enables. I personally think this is true. I've never really understood this trend. I think that one thing that this debate kicks off is what are people getting value out of this? Is this like valuable work? And I don't think that anybody disagrees that there are a lot of companies getting a lot of value out of business process automation and like integration companies like Zapier. I think the question is all like positioning. Why are we positioning this against engineering? I think these are two completely different things.
I think the no code positioning is there because code is terrifying to anyone who's not a developer. And that is also the reason for why so much of the world runs on Excel spreadsheets. We'd of course say, oh, Excel is a reactive functional programming environment. But someone in accounting, let's say, they just think, oh, I can make lists, I can type in some things and other things happen. And I don't need to talk to a single developer to do something that I really care about. That's why the no code positioning, I think, makes sense. It's not aimed at our crowd, it's aimed at other people.
So to follow up on what Hassy was saying, I think the full probably name of it is not no code, is no code development. And so I think people just want to be associated with them doing development as a means to being more productive. And they're using it by not writing code. And it's really their attempt of saying that, hey, we are actually a productive member of the company. And it's the vendor's kind of way to market tools for them. Hey, you can be a quote unquote developer and you can use these no code development tools. However, I think it's weird to put like developers or software engineers on this pedestal and saying, oh, we're just like them. It's like calling marketing as not engineering is weird. You should be just proud of doing marketing, sales, customer success, or whatever it is that you're doing. Not everything has to be compared to development and engineering. Ian, would love to hear your thoughts as well on it.
Yeah, I think of it, this is all of its coding. And I just think of it's like a spectrum, right? On one side, you have, let's say, like low need to understand, like high domain knowledge in terms of like an Excel spreadsheet. I need to understand an Excel spreadsheet, but low requirement in terms of like my depth of like actual ability to go write something from scratch. And on the other end, you have maybe high domain knowledge, but also high depth of understanding in order to build something from scratch. So that's like us and our infrastructure building all these companies. And I think if you look at those two spectrums, when we talk about no code or low code tools, they often tend to be over here in your Excel spreadsheet or your if this and that tool. And really they're being positioned for how do you take someone who classically isn't trained to be a developer and enable them to start doing some things that a developer like. And I think I agree with Hassy in that it tends to be like a market segmentation thing. It's like it attaches, we go after no code. I'm a marketer. Coding is scary, or I don't consider myself a coder. I don't consider myself a developer, but like do use Excel. And if this thing looks and feels and acts like Excel, then maybe I can do it. Right? It's an enabler. And so I do think for now, it's like very much a marketing thing. But from Martine's perspective, agree full-heartedly, like there's code everywhere. And in fact, long-term, we're going to pull more people from not coding into coding deeper, and we'll all have a better understanding. And we'll meet in the middle between abstractions being packaged up and made accessible and the tools having development like workflows. And that'll pull more people from different parts of the organization, but also different types of people and stripes that formulate and actually end up coding. And they may not consider it coding directly in the same way that we don't consider Excel coding, but what they actually are is doing what most of us actually do today is they're gluing things together in a higher level of abstraction.
Didn't someone try to rebrand NoSQL as not only SQL at some point? So maybe I'm going to throw some spice in. You actually don't understand what no code means. It doesn't mean no code. It means not only code.
Yeah, that's an interesting point. But I think in the NoSQL part, it was partially because I think people realized that people actually do like SQL, and there's like, oh, it's not NoSQL, it's like not only SQL. So I think this was one of these cases where after the fact, people wanted to move their positioning. Going back to something Ian said that I actually found interesting. So we see these competing forces right now between higher and higher level of abstraction. Like we just talked about front-end engineers doing more kind of back-end work, and we're now seeing people who are not technically developers doing some workflow automation and things like that. But on the other hand, we now have all these amazing tools like GitHub Copilot that actually, in some cases, I think it was argued that there were like 80% of the code for some tasks, and they obviously will improve with time. So what are your thoughts there? Are we going to see more people writing code with the assistance of tools like GitHub Copilot, or are we going to actually almost see no code and everyone will be just working on a higher level of abstraction?
Just in general today, I think Copilot is a really interesting example of generative AI, right? The ability to write a sentence in natural language and generate code. And that's pretty incredible. And we've seen how much that has improved some developers' workflows, right? The general problem with all these generative AI tools, though, is there's an accuracy issue. Is like, I have to understand what that code's doing for me to know that the resulting code is actually going to work and do the thing I want to do. And so while generative AI may actually like enable us to write more code faster and hopefully improves in its accuracy and correctness in terms of my natural language and results of working code out, I think long-term, and this could be enabled for more people to shift left, you can never really get away the idea of you have to understand what that thing's doing. And this understanding gap is the thing that's missing. And actually, I think this is where these low code or no code tools come in, is they actually are meeting the user where they're at in terms of their understanding. Oh, I'm trying to build a thing that like when I post an image, an Instagram post, it sends out a tweet and then that somehow it results in an email, right? In some weird chain. And they have these drag and drop interfaces that kind of look like coding, but like in terms of the way that they think, it meets them where they're at. And I think that's the fundamental differentiator is like generative AI, great enabler, great productivity booster, but how does it actually help product marketers ever written code automate some of their marketing ops stuff, right? And I think that's the core question I have in terms of how generative AI fits into this equation and how you ever get over that like understanding hump.
I'm just going to say something that I'll probably be really embarrassed about in 5 years. Every single developer that I know, including myself, hates reading code, right? We love writing code. And Copilot generates code for me, so I have to read all of that stuff. That's why I don't think Copilot is going anywhere. But in 5 years, I'll be really embarrassed about having said this.
In 2013 or 2014, I remember there was some debate about whether or when there would be a unicorn which had 0 engineers. And it struck me as an interesting thought because I feel like the asymptote was always pointed at 1 engineer rather than 0 engineers. And I will be, I think after all this stuff, after all this no code stuff, after all of this Copilot stuff, I think at the end of the day, the asymptote is still pointed at one engineer, right? Or like a small number of engineers. And to me, that indicates that the goal of these tools is to enable people to do stuff, not to abstract away the entire business problem or abstract away all of coding or something. There are tools that people can use to interact with their domain more directly. And I think it's interesting that like you fast forward 10 years, there isn't a unicorn that was created by like one person. There's a unicorn that was created by 20 people and stuff like that. But it seems to me that these are all plays on efficiency, and there's a long tail of stuff that's going to get more efficient and which will require fewer people to operate. And so I'm excited to see how that evolves over time. My guess is some people will actually be on autopilot just because it's a fun experience. I don't use it because I think it is going to make me a better programmer. I use it because I hate writing tests.
Let me push back a little bit on the same you meant, Ian, about writing code. So if you take really what is a modern kind of code base today that has a gazillion of dependencies and unfurl it and include all of the lines of code, like no one really reads all of the code that you just get through a dependency, or definitely not if you call a Twilio or a Stripe API, right? You just assume that it works and you just use it exactly as it meant to be used through that interface. Isn't that question of when tools like Copilot will be good enough that you'll just learn to trust them in a way that you really trust in third-party library or a third-party service?
Yeah, it's a great question, right? Because like ultimately what we're operating on when we include like an npm dependency, we do npm install React or something, is you're saying, I trust the people who wrote React have coded to this API that they advertise, and then underneath the API, it works. And then I'm going to go build with this thing, and then I'm going to try and use the thing I've written to make sure that it works. And then when it doesn't, I dig in. And so one of the challenges, right, with generative AI is the signal loss, the lossiness of natural language to code generation, right? There's a level of how much do you describe in natural language before you lose some semantic context about what I'm actually trying to achieve. There's a reason a picture speaks 1,000 words or says 1,000 words, and that's because there's a lot of detail that is communicated in a single image versus what can be communicated in 2 or 3 sentences, and also what can be interpreted based on those 2 or 3 sentences. And so when we think of generative AI, when we think of how this fits in the equation, absolutely. But at the end of the day, when we look at code we include in our code base, someone's actually gone and understands that code. And ideally, there's tests that assert that code work. But at the very beginning of that supply chain of how code becomes trusted and tested is there's a human that's saying, this is what I expect this code to do. And then they're asserting that thing does it. And they do that in many different ways. At the end of the day, like you can never get away from the fact that once we go and generate some code, we have to ensure that the code that's generated is doing what we actually expect it to be doing. And I don't think there's any escape from that ever. And that's why I think like I see these things as like the productivity increasers, but it doesn't solve some of the core fundamental parts of software development, which is what will this thing work under what constraints in what situations, and do I understand what those are?
So basically you're saying you don't believe that we're ever gonna just tell to Copilot, import better version of Kubernetes that is easier to use and 10 times more performant.
Absolutely not. If you read Harry Potter, I'm 33, so I'm a very millennial, so this is relevant to my generation, some not so much, but how many people pronounce Hermione, Hermione differently, right? These are semantic differences. The way that you imagine something occurred or the way someone looked is completely different. And models are no different, right? Models are no different. We're building these statistical models that are based on a bunch of observed stuff that we train, and they're completely subject to bias and experience in the same way that humans are. And so the way that it understands, parses, and generates something is going to be completely dependent upon what you trained that on. And so we're never going to get away from have a 100% solution. We're always going to be iterating closer and closer. It is asymptotic, but there's a point at which we can't make it much better. And the incremental gain in accuracy is so expensive that it can't. So I don't think it's never a question of you never have engineers. You will always have people building systems. There are ways that we can expedite, right, how quickly we build those systems and the complexity at which we operate when we build those systems. But you never get away from the idea that someone has to understand what's being generated and how that system works, because what happens when it breaks?
So Hassy, as the member of the panel that lives closest to where Harry Potter was written, how do you pronounce Emma's Watson character, and what are your thoughts about all the other things Ian said that are far less important?
So confession time, I haven't read the books. I haven't watched any of the films. Personally, I would say Hermione, but could be completely wrong. I'll have to look it up afterwards. I think to go back to Copilot, ultimately it comes back to agency and maybe responsibility. Someone has to be responsible for the output that Copilot generates, which means that someone will always have to read and understand that output. And if that's not the case, then when something goes wrong, say in a high stakes situation, who gets the blame or who assumes responsibility? In my opinion, that's what kind of precludes that scenario of Copilot just generating things for us completely autonomously from ever happening.
I think everybody agrees that code is for people, not for machines, right? Classes don't exist. They're not real. They're for us. So I think that indicates that there are two ways that this could go. On the one hand, it is perhaps true that there is a lot of code out there where it is not that important, that the abstraction is not the most important part of it, right? Like tests. The other way that this could work is Copilot just gets actually super good at providing abstractions that humans want to use, understand, and can. I think most people agree that the second of those is like machines making abstractions that other humans can want to maintain is like less likely. So it seems to me that for Copilot to make significant inroads and be responsible for a lot of code that people use every day, it has to be the second. It has to be the case that the domain of places where it is not important that people understand and maintain an abstraction is a lot larger than we think it is. And personally, for me, I have trouble believing that outside of the use cases that I use it for, which is like generating boilerplate calls to like APIs and tests and stuff like that.
Yeah, I think a lot of the excitement around Copilot actually brings into focus just how much boilerplate we write as an industry. And shouldn't we maybe have better abstractions in our languages or frameworks, which kind of make a lot of that code that Copilot writes for us that we get excited about completely unnecessary.
And with that, we can wrap up the 5th episode. Hassy, Ian, Alex, thank you so much for joining us today. And for all the listeners, thank you for listening.